Hello and welcome once again to the Clements Corner. Here is your dashing and brilliant host, Mr. Clements. Yes, I finally caught my 100th tarantula. Oh snap! So, continuing with our lesson on Newton's laws. This episode is all about Newton's second law. This law states, the net force on an object is the product of its mass and acceleration. Product means that they're multiplied together. We show this relationship mathematically using the formula F equals ma, where F is the force in newtons, m is the mass in kilograms, and a is the acceleration in meters per second squared. This formula allows us to make several predictions if we know some of the variables. One key thing that we have found through this formula is the acceleration of Earth's gravity. If you drop something on a force sensor after measuring its mass, you can calculate the acceleration due to gravity. It's physics! This has been the Clements Corner with Mr. Clements. Now enjoy the rest of your learning experience. Tune in next time to hear Mr. Clements talk about the physics behind the shoot and the floss. Force. Force is something that we use every day. When we're walking, when we're eating. Ugh, too much. Oh, there's another one? Oh, should have only done one. Nope, next, please. Music. When we're conducting, or when we're playing. Even video games need force. You gotta use force to push the button and pwn the noobs. That brings us to weight. Weight is a type of force. Specifically, it's the force of gravity, pulling things to a bigger mass. The formula for weight is W equals mg, where W is weight in newtons, m is mass in kilograms, and g is the acceleration of gravity, which is always 9.8 meters per second squared. This is basically the same formula as F equals ma. Important info for remembering about weight is mass and weight are very different. Mass is how many atoms make up something, and weight is the force of gravity acting on the mass. But what is a force? A force is simply a push or a pull on an object. Any push or any pull acting on an object. Some things to remember about force. More mass means more force. More acceleration means more force. And more mass means less acceleration only if the force is constant, and vice versa. More acceleration means less mass. You probably already noticed, but this video is a lot shorter, and that is because it's really hard to do this particular law of Newton's without a bunch of math. And I didn't want to put math in the video because you're going to have to do math on the worksheet. So there are only two experiments, two demonstrations. The first one that's coming up is going to be testing what happens if you have the same acceleration but different masses. How does that change the force? So that's what we're going to do first. The second one is going to be a constant force but different masses and see how that changes the acceleration. So without further ado, here's the first demo. So in this experiment, we've got two balls, a marble and a steel ball. The only difference between the two is their mass. One of them is more massive than the other one. It's got more atoms inside of it. What we're going to do is we're going to hold both of these above a light bulb and then drop them. And due to gravity, they will have the same acceleration, but they have different mass, which means they should have a different force. First up, we've got the marble. And now, the steel ball. So as you can see, the one with more mass, the steel ball, is the one that broke the light bulb. Even though they were dropped from the same height and they had the same acceleration, the one with more mass had more force and was able to break the light bulb. So that was the first one. Second demo, this is the one where we're going to have constant force. I'm actually going to use a catapult that I built myself. You're free to build one of your very own and try this yourself if you'd like. It's just popsicle sticks and glue. So super easy. Oh, and rubber bands. Anyway, super duper fun, really simple, and we're going to see how mass can affect the acceleration. Here it goes. For this experiment, we've got the marble and the steel ball from the last one, and this time we're going to be using a catapult of my very own creation. Wow! So this is trial 1 with the steel ball first. You can see how ultra powerful and strong my catapult is. It sent the steel ball about 9 centimeters. Up next we've got the marble. And you can see that it went much further. It got about 61 centimeters. Same force, further distance. So now the question is why? Why did the marble go further than the steel ball? The reason is because the force is constant, right? It's the same catapult each time. It didn't change anything. So the force of the catapult is the same, but the steel ball has more mass. So if the steel ball has more mass and the force is the same, that means that the acceleration is going to be less. If the acceleration is less, it doesn't go as far. So that means that for something with less mass, like the marble, the acceleration is going to have to be more in order to have the same force as before. So that's why the marble went further, is because it had more acceleration, because it had less mass. Well, that just about does it for this video. Thank you guys so much for watching. Again, special shout out to the artist who did the drawings at the beginning, Runty Art. If you want to check out her stuff, here are some links. See you guys later. Have a good one.